Good morning, students. Welcome to 10th Science, Unit 11, Carbon and its Compounds, Part 3. Now, let us recall what we learnt in the previous classes. Introduction to Organic Compounds. What are organic compounds? Carbon, they combine with other elements to form a large number of compounds. There is more than 5 million compounds. Classification of organic compounds based on the pattern of carbon chain. It is classified into open chain compounds and closed chain compounds. Classes of organic compounds based on the kind of atoms. It is classified into alkane, alkene and alkynes. Characteristics of hydrocarbons. What are hydrocarbons? Organic compounds that are composed of carbon and hydrogen are called as hydrocarbons. Classification of organic compounds based on the functional group. The functional groups are alcohol, aldehyde, carboxylic acid and ketone. Then the last one, nomenclature of organic compounds by using the IUPAC rules. IUPAC nomenclature of hydrocarbons using the Sol examples. What are the components of an IUPAC name? Prefix plus root word plus suffix, it gives the IUPAC name. Prefix represents the substituent or branches present in the carbon chain. Root word, it represents it describes the skeleton of the carbon chain contained in the parent carbon atoms. Then suffix, it is classified into primary suffix and secondary suffix. In the primary suffix, a compound contains a single bond. It is the suffix used is ane, double bond means ene and triple bond means yne. The secondary suffix is the functional group, that is alcohol, aldehyde, ketone and also carboxylic acids. So prefix plus root word plus suffix, it gives the IUPAC name. By using the IUPAC rules, now you have to write the name of the compound. Example 1. CH3 bond, CH2 bond, CH2 bond, CH2 bond, CH3. According to the rule 1, identify the longest chain. Here, you are having a 5 carbon atom. 1, 2, 3, 4, 5 carbon atoms. Here, so the step 1, it is a 5 carbon atom means the root word is pent. Then step 2, all the bonds between the carbon atoms are single bonds and the suffix is ane. So the name of the compound is pent plus ane, that is equal to pentane. The name of the compound is pentane. Example 2. Now come to the second compound. Now identify the longest chain. Here CH3 bond CH, bond CH2, bond CH2, bond CH3. Here totally 5 carbon atoms. 5 carbon atoms means the root word is pent. But the second carbon, a substituent or a branch is present in the carbon chain. So the substituent is a methyl group. A second carbon, a methyl group is present. So the name of the compound is 2-methyl pentane. All are single bonds. So the suffix used is ane, 2-methyl pentane. So how to write in a stepwise? Step 1. The longest chain contains 5 carbon atoms and hence the root word is pent. Step 2. All are single bonds between the carbon atoms and the suffix is ane. The second carbon, step 3, the substituent is a methyl group, CH3. CH3 is the methyl group and it is located at the second carbon atom and its locant number is 2 and thus the prefix is 2-methyl. So the name of the compound is 2-methyl plus pent plus ane, that is equal to 2-methyl pentane. The name of the compound is 2-methyl pentane. Then example 3. Now identify or find the longest chain. Now come to the compound here. CH3 is bond CH, bond CH2, bond CH2, bond CH2, CH3. So here 1, 2, 3, 4, 5, 6. Only it contains 6 carbon atoms. But here this chain contains 1, 2, 3, 4, 5, 6, 7. Heptane. So hept, the root word is hept. So first you have to find the longest chain in the carbon atom. Here the longest chain contains 7 carbon atoms. So the root word is hept. A third carbon, a methyl group is present or substituent is present. Here branch chain is there. This is a methyl group. The substituent is a methyl group. So a 3-methyl heptane. So the step 1, the longest chain contains 7 carbon atoms and hence the root word is hept. All are single bonds between the carbon atoms and the suffix is ane. The substituent is a methyl group. A third carbon, a substituent or branch chain is here. Branch is present here, CH3. So it is a methyl group. A methyl group, it is located at third carbon. So its locant number is 3. And thus the prefix is 3-methyl. Hence the name of the compound is 3-methyl plus hept plus ane, that is equal to 3-methyl heptane. The name of the compound is 3-methyl heptane. Example 4. First, you come to the compound CH3, bond CH2, bond CH2, bond CH, double bond CH2. Here only one chain here, but how to numbering the carbon atom from the right side or the left side? You have to numbering from the right side because a double bond is attached with the first carbon, the carbon to carbon double bond which has the lowest possible number. So you have to numbering from the right side. 1, say 2, 3, 4, 5. So 5 carbon means pent. A first carbon, a double bond is there. So pent 1 ene. The name of the compound is pent 1 ene. Now write in a systematically stepwise. Step 1. It is a 5 carbon chain, atoms chain, and hence the root word is pent. Step 2. There is a carbon to carbon double bond. So the suffix uses ene. The step 3. The carbon chain is numbered from the end such that double bond has the lowest locant number. Then step 4, the locant number of the double bond is 1. A first carbon, a double bond is attached. So, the suffix is 1 ene. The name of the compound is pent plus 1 ene. That is equal to pent 1 ene. The name of this compound is pent 1 ene. The next one, IUPAC nomenclature of other classes solved examples depends upon the functional group. There are 4 functional groups: alcohol, aldehyde, ketone, carboxylic acid. Example 1. CH3 bond CH2 bond CH2 bond OH. So, here you have to numbering from the right side. You have to number the carbon 1, 2, 3. 3 carbon means the root word is prop. A first carbon, a functional group is attached here. This is a alcohol. alcohol, the suffix used is OL. So a first carbon, a functional group is attached. So propane 1 ol. Propane 1 ol. So step 1. The parent chain consists of 3 carbon atoms. The root word is prop. Then there are single bonds between the carbon atoms of the chain. So the primary suffix is ANE. Step 3. Since the compound contains OH group, it is an alcohol. The carbon chain is numbered from the end, which is closest to the functional group, that is OH group. Step 4. The locant number of OH is attached with the carbon, that is 1. So the secondary suffix is 1 OL. A first carbon, a functional group is attached 1 OL. The name of the compound is prop plus A plus 1 ol. You have to remove this E and you have to put 1 ol. Propane 1 ol. So the name of the compound is propane 1 ol. Example 2. CH3COOH. Here, count the carbon atoms. 1, 2. 2 carbon means the root word is eth. So the step 1, the parent chain consists of 2 carbon atoms. The root word is eth. And here step 2, all are single bonds between the carbon atoms on the chain. So the primary suffix is ANE. Step 3, since the compound contains COOH, COOH is a carboxylic acid. The secondary suffix is oic acid. So ethane, the name of the compound is eth plus ANE plus oic acid. So you remove this E and oic acid. Ethane. In ethane you remove the E and put oic acid. Ethanoic acid. The name of the compound CH3COOH is ethanoic acid. Now come to the various classes of organic compounds. Depends upon the IUPAC name. Here the first one, alcohols. Alcohols, the functional group is OH. And the general formula is ROH. And the suffix used is OL. Now let us remember the member of the alkane. 1 carbon, methane contains 1 carbon. So that is methane. 2 carbon means ethane. 3 carbon means propane. 4 carbon means butane. 5 carbon means pentane. So these are the member of an alkane. Here in the number of carbon atoms, molecular formula, IUPAC name. Here only number of carbon atoms, the molecular formula is CH3OH. Here only 1 carbon, so methane. Methane, a functional group is attached. Alcohol, OH is the functional group. So the suffix used is OL. So that is methanol. Methane means METANE. You remove E and put OL. Methanol. Second number of carbon atoms 2. CH3, CH2OH. Ethane, ethanol. Number of carbon atoms 3. CH3, CH2, CH2OH. A functional group, alcohol. So propane, E, remove E and put OL. Propanol. Number of carbon atoms 4. CH3, CH2, CH2, CH2OH. OH is the functional group. So butanol. Number of carbon atoms 5. CH3, CH2, 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 CH2OH. 5 carbon atoms, 1 functional group, alcohol. Pentane, OL, that is pentanol. Methanol, ethanol, propanol, butanol and pentanol. The next one, aldehyde. The functional group of aldehyde is CHO. The general formula is RCHO and the suffix used is Al. The number of carbon atoms 1. The molecular formula Here RCHO, in the place of R we put H. So the molecular formula is HCHO. Here only one carbon means methane, and you remove E and put Al. Aldehyde, it is the suffix used is Al, that is methanol. In the place of R we put CH3. CH3CHO, it contains two carbon atoms, that is ethane, ethanol. In the place of R we put CH3CH2, that is CHO is the functional group. So CH3CH2CHO, 3 carbon means propane, aldehyde, the suffix used is Al, propanol. Then number of carbon atoms 4, CH3, CH2, CH2, CHO. Here 4 carbon means butanol. 5 carbon CH3, CH2, 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 CHO. Totally 5 carbon atoms, but a functional group, that is CHO, aldehyde, that is pentanol. Methanol, ethanol, propanol, butanol and pentanol. The third one, that is carboxylic acid. The functional group of carboxylic acid is COOH. The general formula is RCOOH and the suffix used is oic acid. The number of carbon atoms, in the place of R we put H. COOH is the functional group. So COOH is the acid. So the name of the IUPAC name of the compound is methanoic acid. Only one carbon means methane. You remove E and put oic acid. Methanoic acid. Now in the place of R we put CH3. COOH is the functional group. Here 2 carbon atoms. 2 carbon means ethane. A functional group is the carboxylic acid. So that is oic acid. Ethanoic acid. The third one, number of carbon atoms 3. CH3, CH2, COOH. That is 3 carbon means propane. This is propanoic acid. Number of carbon atoms 4. CH3, CH2, CH2, COOH. Number of carbon atoms here 4. Butane, the functional group COOH, that is butanoic acid. Here number of carbon atom 5. CH3, CH2, 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 COOH. Here totally 5 carbon atoms, but a functional group is here. So pentanoic acid. 1 carbon means methanoic acid, 2 carbon means ethanoic acid, 3 carbon means propanoic acid, 4 means butanoic acid, and 5 means pentanoic acid. Now come to the last one, that is ketones. Ketones, the functional group is CO. The general formula is RCOR and the suffix used is 1. Here in the place of R we put CH3. Here also here CH3, CO, CH3. So totally 3 carbon atoms. So here the number of carbon atoms, here starting from the molecular formula, here 3 carbon atoms. So number of carbon atom here 3. CH3, CO, CH3. Here for 3 carbon means propane. Here this is a ketone. CO, the functional group is the ketone. Ketone means the suffix used is 1. So this is the IUPAC name is propanone. Then number of carbon atoms 4. CH3, CO, CH2, CH3. So that is 1, 2, 3, 4. 4 carbon means butane. Functional group is a ketone, that is butanone. The next one, number of carbon atoms 5. CH3, CO, CH2, CH2, CH3. Totally 5 carbon. Here a functional group is the ketone, that is pentane, pentanone. So these are the functional group. The IUPAC name of the alcohol, aldehyde, carboxylic acid and ketones. So write the above 4 tabular columns in the long size notebook. Thank you students.